This video will be on how to graph general rational functions. You should have hopefully already watched the previous video on graphing simple rational functions because it lays a good foundation for learning the things we need to today. We will begin by looking at this table here, and you have seen this kind of notation before for a polynomial function. So let's just go over it again. What it's saying today is the new function that will be created comes from dividing one function by another function. And up here you've seen this notation before, where simply this is the highest power in the polynomial and it goes down standard form, so there's the minus 1 power. And these letters, a, m, are the coefficients of those powers that are associated. This last term is the constant. And this time we're just going to be dividing it by another polynomial. So that's really all that this notation means. Here come the important parts for graphing rational functions. The new element we're going to be adding when we're graphing is x-intercepts. We can find the x-intercepts of a rational function by looking at the real zeros of p of x. Now p of x is just the numerator here. So don't think it's saying anything special, and hopefully you remember what real zeros means. It simply means that we are going to factor the numerators or solve them for x. These solutions will be your x-intercepts. The second step here is to find the vertical asymptotes, and this is not new if you watched that previous video. The vertical asymptotes simply come from the zeros of the denominator. Realizing that you cannot divide by 0, we need to eliminate any values of x that would create a 0 in that denominator. So all we need to do is solve the denominator for x, and we will have our vertical asymptotes. Now step 3 is helping us find the horizontal asymptote for any rational functions. And this is important to remember that what we're going to be comparing here is the degrees. The degree of the numerator we'll call m, and the degree of the denominator we're going to label with an n, and you can see them up here. Here's your m and there's your n. And you find your horizontal asymptotes by comparing the degrees. So first off, if you compare your degrees and the degree of the numerator is less than the degree of the denominator, you will have a horizontal asymptote at y equals 0. If the degrees are equal, you will simply take the leading coefficients and divide them as you did in the previous video. That will be the location of your horizontal asymptote. If the degree of your numerator is greater than the degree of your denominator, you have no horizontal asymptote. So you're going to need to use this chart to help you decide where your horizontal asymptotes are. Let's show you an example. Here is a rational function where you have a constant 6 in the numerator and x squared plus 1 in the denominator. So you have a horizontal line being divided by a quadratic function. Remember, there are 3 important characteristics of this graph that we need to analyze before we graph it. The first is our x-intercepts. If you look back at the chart, it says your x-intercepts will be determined by the solutions of your numerator. And so if I was asked to solve this numerator for x, hopefully you're a little confused because there is no x. So in this case, because I have no x to solve for, or no zeros, we have no x-intercepts. And it's important to write the word none. Okay, so we have no x-intercepts here. The second important characteristic was our vertical asymptotes. And remember, our vertical asymptotes come from the denominator, or any 0 that would be created in the denominator. So simply set your denominator equal to 0 and solve it. Now here's another problem. When I attempt to square root both sides of this, hopefully it's triggering a memory that we're going to get an imaginary number here. And if you go back to the chart, you will see that it has to be a real 0. This is an imaginary 0. And so we have no vertical asymptotes either. Step 3, or characteristic 3, is looking for our horizontal asymptotes. And remember, that comes from comparing the degrees. So let's look at the degree of our numerator. Remember, the degree is the highest power attached to a variable. Well, I don't have a variable. The only way that would have happened is if I had x to the 0 power. So the numerator's degree is 0. The denominator's degree, which we indicate with an n, is a 2. And so we compare these and we see that the degree of our numerator is less than our degree of our denominator. I should have wrote an n there. Now go back to your chart and see what you do when the degree of your numerator is less than the degree of the denominator. And it says in that very first line that your horizontal asymptote will then be the line y equals 0. So now that we have all this information, we can go over and start plotting what we know. We had no x-intercepts, we had no vertical asymptotes, but we did have a horizontal asymptote at y equals 0. After you've plotted all those characteristics, your next step is to do what we did in the previous video, which is to plot points to the left and the right of the vertical asymptote. But I don't have a vertical asymptote, so what do you do? We're just going to start plotting some points that are located around the origin and try to see how this graph is behaving. Do as many as you need, but I'll start you off on this one. And so I graphed points at 0 and 1, and I looked what was happening at a -1 and a -3 and a +3. That's kind of out of order. But when I shove those into the original rational function, I get the following coordinate pairs. And these will be sometimes nasty fractions, but all we can do is estimate. So if you go ahead and plot these coordinate pairs, you can kind of see the shape start to emerge. And it's important to remember how your graph is going to behave as it's approaching those asymptotes. And so it's going to get closer but never touch across. And you'll have to use your imagination, I guess, on that one. I did the best I could. So that is the shape of this polynomial rational function using the characteristics we described. Let's try another one. So let's dive into this rational function. It looks like I'm dividing a quadratic equation by another quadratic equation, and remember, we need to look for x-intercepts, vertical asymptotes, and horizontal asymptotes. You need to recall that x-intercepts are coming from the zeros of the numerator. It's just something you kind of need to memorize. And so when I take my numerator and set it equal to 0, divide by 2, and then square root, you can see that you have an x-intercept located at the coordinate pair 0, 0. So you could go over and shift this and plot 0, 0. Then I'm going to look for my vertical asymptotes. Those come from the denominator. So I have x squared minus 9 equals 0. Solve it for x squared. Square root both sides, and don't forget your plus and minus. There are 2 roots to the square root of 9, which indicates we have 2 vertical asymptotes, which may be new for us. And so I will go plot those. One is at 3. And the other vertical asymptote is at -3. Our horizontal asymptotes come from comparing the degrees. So the degree of my numerator is 2. That's coming from this squared power right there. And the degree of my denominator is also 2. And if you go back and look at the chart, it says when your degrees match that you take your leading coefficients and divide them to find the location of your horizontal asymptote. So my numerator's leading coefficient is 2, and my denominator's leading coefficient is 2. So y equals 2 is the location of my horizontal asymptote. Now we get to the point where we need to plot points to the left and right of the vertical asymptote. So this is kind of new for us too, because I have 2 vertical asymptotes. So you're simply going to take some points to the left of, we'll say, this asymptote, and the points I will pick for that are a -4 and a -6. So these are to the left of my one vertical asymptote. Then I'm going to plot some points in the center of the two asymptotes, and I already have 1 point there, so I'm just going to look at what's happening when x is a -1 and when x is a +1. And finally, we need to look to the right of this asymptote. And so to the right of that asymptote, I will pick 2 points, let's say 5 and 7. So you go and you substitute these x values into your original equation and see what comes out. Now be careful with those order of operations. Like I've said before, if anything's going to screw people up, it's getting that order right. And here are the numbers that will be your outputs that we will have to plot. When I put in a 5, I got about a 3.1, which is just a 3 when we graph it, and this is like about a 2.5. So go ahead and plot those 6 coordinate pairs, which should look like that. And then it becomes your job to kind of fill in the spaces and figure out how this graph is behaving. If these were not enough points for you, feel free to plot more points. There's nothing stopping you. But knowing how your branches behave as they approach asymptotes is super helpful. It's kind of determining that this is approaching those asymptotes in that way. It looks like a face-down parabola. And this one mirrors the left side as well. So this is how that beautiful graph ends up looking. If you weren't sure, you could certainly do it on your calculator and see how that looks. But as far as importance goes, filling in the actual graph, I don't know, to me is less important than actually being able to see those characteristics of what the graph should look like. So don't stress over this part, the connecting the dots part. It'll work itself out. Let's try one more example together. So write down this rational function and we'll get started working on it by looking at the x-intercepts, where the vertical asymptotes are, if there are any, and then the horizontal asymptote, if there are or is any. Alright, this one's fun. As you recall, your x-intercepts come from the numerator. So when you see x squared plus 3x minus 4, factoring those quadratics should come back to your mind. That's a square. And we're going to factor this trinomial into the two binomial factors. And so we're going to get x, and that equals a 0. And so we will get x plus 4 and x minus 1. And then solving that, you'll see x is a -4 and x is a +1. Remember, these are coordinate pairs for your intercepts. So let's shift over here and draw in our -4 intercept and our +1 intercept. And see how this comes together. Vertical asymptotes come from the denominator, so I have x minus 2 equals 0, setting it equals 0, so I can see that x is not allowed to be a 2, and so we need to eliminate that from our possible input values, and so we have a vertical asymptote at x equals 2. Horizontal asymptotes come from comparing the degree of the numerator, which is this 2 here, and my denominator's degree is a 1. So comparing those, we see that m is greater than n, and when that happens, we have no horizontal asymptote. It's important to say no or none if something doesn't exist. You don't want to say 0 because then it's implying that there's a horizontal asymptote at y equals 0. So be very careful with using the number 0 versus words like none or no. Alright, well that's not very helpful there if we have no horizontal asymptote. Here are 4 rational functions that you can graph. I only have 3 graphs, so I'm just going to graph 1 and 2 and 4. If you want to do 3 as well, go for it. You can always do these on your calculator. So pause the video now and get started. You know the 3 elements I'm looking for, and then make some tables and see how these turn out. Pause the video now.